idea that the Germans had secret weapons became more and more prevalent among the Allies. Despite differences of opinion in the High Command as to the existence of such weapons, the doubts persisted, and the bunker in Epelec was placed under close aerial surveillance. The Allies could not imagine that this vast site was to become an assembly factory and a launch base for the terrifying V2s. But to better understand what exactly is a V2, let's compare it with the V1.
Designed by the German Air Force, the V1 was a flying bomb which looked like a small aeroplane without a pilot. Takeoff was horizontal. It was a copy of the principle of an aircraft carrier. A launch ramp 150 feet long, with a 10% gradient, was set up in the direction of the target. Placed at the foot of the ramp, attached to a piston, the V1 was propelled using the chemical reaction of hydrogen peroxide on potassium permanganate. This reaction drove the rocket and launched it into the sky at a speed of 400 miles per hour. With the V1, we witnessed the first industrial use of the pulse jet. The fuel used was kerosene, and the range was up to 190 miles. Flying at a height of 8,000 feet, it reached its target by means of an anemometric distance meter, or simply by running out of fuel. Technologically, the V2 was much more sophisticated. Designed by the German Army, it was the ancestor of our modern rockets. Launched vertically, a thrust of 25 tons lasting 65 seconds lifted it off the ground and propelled it at a speed of Mach 4, or more than 3,100 miles an hour, for a distance of 70 miles. As it didn't leave the atmosphere, the V2 did not go into orbit and fell back to Earth. Its ascending curve was maintained by a system of integrated accelerometer gyroscopes, the first industrial series production of an inertial platform. The fuel, ethanol, and the oxidant, liquid oxygen, were piped to the combustion chamber by a turbo pump, triggered by the reaction of hydrogen peroxide on permanganate.
We now have a better understanding of the power of the V2. Faster than sound, it was impossible to intercept at the time. 5 times heavier and flying higher than the V1, the V2 hit the ground with a weight of more than 1 million tons, causing an air blast and a veritable earthquake. With the same explosive charge, the V2 was much more lethal than its predecessor, the V1.
Given the numerous adjustments required before the launch of a V2, it was decided that they needed launching from strongly protected bunkers. All the more so, as the transport of liquid oxygen used to launch the rocket was considered to be too dangerous, and the bunker could therefore also be used for storage. When, on the 22nd of December 1942, Hitler ordered the construction of a bunker in the north of France, Oberstleutnant Tom was put in charge of finding the site. From the outset, the most favorable area was between Saint-Omer and Boulogne, the hilly terrain being ideal for finding old quarries to be used for the construction of such a building. Also, easy rail and river communications would enable the transport of the large amounts of material required for the job. After examining a number of sites around Zouavk, near Nordosk, it was the region of Epelec that was chosen for its high logistic value. A double-track railway line linking Calais to Lille, a navigable canal for large-gauge barges, the existence of high-voltage power lines, a highly developed road network, and finally, forest ground on the counterslope in relation to England.
Just look at this gigantic wall of concrete. The south face of the bunker housed the liquid oxygen factory. 245 feet long, 115 feet wide, 109 feet high, of which only 73 feet are visible. and yet this bunker only represents a little more than a third of the dimensions originally planned. In the middle of this frontage, there's a pentagonal structure. It is the lower part of the control tower of the original bunker. Its height indicates the level of construction that was reached before the 27th of August 1943, date of the first bombardment. The launch of the V2s was to be operated from this control tower. They were to be moved from inside the bunker to the launch pads exactly where you're standing now, being brought through the 58-foot high gateways located on each side of the tower. Look at the numerous openings along the frontage. These are openings for pipes used for the air supply of the bunker and for compressors for the production of liquid oxygen. According to the project's plan for the bunker, its maximum capacity was to have reached 36 rockets per day.
But the Allied bombing on the 27th of August 1943 put an end to the plan for launching V2s from Epelec.
You are now on what seems to be a raised concrete platform below the forest. You have a general view of the whole of the northern part of the bunker, a view dominated by its impressive front wall. In fact, you are on top of the north wall of the bunker. This unfinished wall, 16 feet thick and 36 feet high, was initially going to be as high as the one facing you. This northern part of the bunker would then have been covered by a 16-foot thick roof slab. Look at the plans in front of you. The section on the right, fully 1/3 of the total area, was never finished. You can imagine the huge proportions the first bunker must have had.
At point number 1 is the floor of the second level, reserved for the storage and assembly of the V2s without their warheads. This hall was to have had a height of 46 feet and was intended to contain around 120 rockets. Opposite you, adjoining the north face of the bunker, at point number 2 on your plan, is the storage area for the liquid oxygen coming from the production factory at point number 8. Either side of this area, at point number 3, were the transfer galleries through which the rockets would have been moved to the fuel and launch preparation stations, point number 4. Once prepared, the V2s would have been taken through the lateral corridors, point number 5, to be taken outside the bunker to the launch pads at point number 6. The launch was operated from the control tower at point number 7. You can also see the gaping hole in the floor on this level left by a big bomb. The enormous concrete block on the roof of the liquid oxygen storage area was ripped off by the explosion of a 6-ton tall boy bomb. You can still see the impact of this bomb on the northern edge of the bunker roof.
Behind you was one of the large ready-mix cement plants which supplied the original bunker. The existing bunker was chiefly supplied by a plant located much higher up and which was damaged during the numerous bombardments. Around you can see a large number of bags of cement which have solidified. The concrete produced by the plant was pumped through to the site by special pumps. At this level, a large number of feed pipes and directional spouts distributed the concrete to the various shuttering points. Because of its shape, the Germans called this system the spider. As for the finishing and leveling work, this was carried out by young Belgian workers using wheelbarrows and quarries. Further down, a commemorative plaque honors the memory of the young Belgians who worked at the cement plant.
Try to imagine the huge work site required for the construction of such a building. In 1 year, 35,000 workers relayed each other to erect this concrete monster, a real human anthill.
The work began as of March 1943, following the original plans of the Todt organization. Mechanical diggers, winch bulldozers, decobial tracks for steam locomotives, cranes, gigantic concrete mixers, and a multitude of construction machines invaded the forest of Interlaken. Day and night, under floodlights, 3,000 laborers toiled ceaselessly. More than a third of the works were finished. Over 1.5 million cubic feet of concrete had been poured when, on the 27th of August 1943, a dull sound was heard in the distance.
After an hour of intensive bombing, the damage is heavy. 185 flying fortresses have just dropped 366 one-ton bombs on the Epaulet worksite. The northern part is devastated, and there are many victims among the workers. As we remember this air raid, let us spare a thought for René Mouchot, commander of the Free French Air Force, who was shot down while escorting the American bombers. In the east corner of the bunker, a commemorative plaque honors his bravery and reminds us of his sacrifice.
Following this bombardment, the Todt organization judges the use of the bunker as a launching site for the V2s to be impossible. On the other hand, the southern part of the building having remained intact, the Germans desperately want to finish their liquid oxygen factory. It's then that an engineer by the name of Floss has an extraordinary brainwave to pursue the work by using the so-called tortoise method. To shelter from the bombs, the workers lay a concrete slab, 16 feet thick, divided into 3 sections representing a volume of over 460,000 cubic feet for a weight of around 35,000 tons of reinforced concrete. This slab is to be the roof of the factory. By means of jacks, levers and blocks, the roof will be raised. The formwork for both the outer and partition walls will be laid and armored, and the concrete injected by means of huge pumps. When the walls are sufficiently dry and resistant, the same operation will begin again to lift the building out of the ground like some huge mushroom.
For the work itself, the German authorities used a great number of Russian, Yugoslavian, Polish, Czech and Belgian prisoners, and of course French members of the STO, the compulsory labor service, whose memory we respectfully honor. Thanks to this so-called tortoise technique, the Epelec bunker became invulnerable to the repeated bombardments which followed the raid of the 27th of August 1943. And finally, in January 1944, the superstructure housing the liquid oxygen factory was finished in the state you see before you now.
Here, you are at the heart of the Epelec bunker. The colossal door that you've just come through closed the passage to the railway lines. It is 7¼ feet thick. Over 3,000 cubic feet filled with concrete. Over 215 tons in motion. This door is once again in working order since its restoration in 1988 using electric motors. Suspended by 2 connecting rods to a 4-axle carriage, it moves by means of a gear system on 2 rails resting on the consoles above you. Look at the impressive height of the hall housing the railway. The planned height of 82 feet was to allow the transport and preparation of the terrifying V2s. Today, it's just 72 feet high, because the tunnel has received a 10-foot backfill in order to raise the floor level above the groundwater and to enable you to enter the bunker. Halfway up the hall, there are 3 levels where the liquid oxygen tanks were finally placed, enabling the loading of isothermal wagons. These wagons, with a capacity of 15 tons, could supply up to 3 V2s. Today, the side corridor shelters the life-size reproduction of a V2, measuring more than 46 feet. From this opening, the rockets were to have been moved outside the bunker to the launch pad. The deflectors, still visible on the walls, were designed to reduce the shock wave from the rocket blast. Exhaust gas outlets were placed at the top of the corridor.
The question remains, why did the Germans finish this type of work when officially the Epelec bunker was no longer anything more than a production unit for liquid oxygen? We might suppose that the engineers of the top organization had not completely abandoned the idea of using the Epelec bunker as an independent base for the assembly and launch of V2s.